Hello, hope you all are doing okay. Today we're going to dive into stats a little bit more deeply, and we're going to take a look at a theme that is probably half of what we'll be looking at throughout the term. If we think about what stats is all about, it's all either about central tendency or variability. So really all we're looking at is central tendency. We'll be looking at the definition here in a little bit. But it's basically, we're looking at two things in stats. Either up above, we're looking at, sorry about it jumping like that. Either one, how things are the same, and number two, how things are different. So these are basically the idea of if you get a table of information, a table of data, and you look at it across, you gather it all together and look at the patterns you see. Half of what we'll be doing in our class is looking at how things are the same, and the other half is looking at how things are different. So today we're going to be kind of looking at the main measures of sameness, or how we notice that things look the same over time. So the sameness in stats is going to be averages, and specifically mean, median, and mode. So average is the term, the collective term of all three of these, but each three of them has their own specialty and things that they point out. So we'll be looking at these for the next few weeks, but essentially we're going to look at the overall idea of each of them today. Okay, so commonly referred to, and the reason these are important is when we talk about averages, people, when you see it on the news or on TV, it's generally used averages as a catch-all phrase. So the average American or the average student thinks this, or the average voter thinks this. Average could mean one of these three things. So it's important for us to be able to distinguish these so that we can make our own determination on whether the story that someone is telling us is something we believe. So as we go down here a little bit, so I want to start exposing us to this normal curve now. And honestly, we'll be looking at this curve probably almost every week as we go through this course. And this is just a normal curve, a normal distribution. So when we're looking at this, it's you probably have seen it before. Maybe it normally is on a scale that looks like this on the x and the y axis. When you're looking at this, it's maybe in science, but basically we're going to be breaking down this curve throughout the next few weeks and start being able to determine what each aspect means. So when someone gives you a curve like this, you'll be able to make some educated guesses about a population just by looking at this curve, because it gives us a lot of information. So again, so we're looking at central tendency, and basically that's the measure of sameness, and it's looking at this part of the normal curve, this big center part, central tendency, because the tendency for information is it's going to tend to bunch towards the middle. So that's why we're looking at this. Central tendency is a tendency to go towards the center. As you can see here, it's smaller on this end. Do it a different color. It's smaller on this end and this end, but it's the biggest here in the center. So the reason we're going to be looking at that is this is where the bulk of the information is, so this will tell us the most generalities about any data we're looking at. And the other interesting thing about this, and we'll talk about this throughout, but the interesting thing about normal curves is they basically characterize nearly any population. So if you get enough people, places, animals, etc., their characteristics, and put it on a normal curve, eventually it's going to start looking like this chart here. So basically what I'm saying is if you were to get something like, if you got the height of everybody at the school, eventually if you plotted them all down, if you got one, if you got etc., everyone's height for every person in the school, and you put it all on a chart, there's going to be a big portion of people that are going to be in the middle. So for instance, the average, I think, in the United States for men is something like 5'9". So you would see that the majority of people in any population are eventually going to start going towards a central tendency, towards the middle. And you would have a few people on either end, shorter folks on one end and very tall folks on the other, as a small part of that population. It would be the same thing if you did weight, the same thing if you did income, the same thing if you, and this goes for nature as well, if you did that for heights of trees, average age of a dog or a cat, it's going to start looking like this. So The reason this is important is because we know that things to start look like this normal curve, it means they could give us a lot of opportunities to take a look at information and be able to tell a really good story about voting habits, about people's beliefs and values, and any information you possibly want to get about any group of people. Okay, so we'll take this, and this will be kind of the basis for what we talk about this week and the next few weeks, as far as looking at central tendency or sameness. So let's take a look. So basically, we're just looking at 3 different ideas. I'll start off with the easiest one. So there'll be 3 types here. Type 1 is mode. And mode is just, it's the category or score with the largest frequency or percentage. Okay, so basically any grouping you got, and this is something we looked at last week, if you were to go through which is the mode of the category. So for instance, if I were to ask, what is the mode of degree? You could go through, it's pretty easy to see. You would see that high school comes up a lot of times, and I think if I remember correctly from last week, high school comes up 24 times. So the mode for this, if you went through and counted all of these, so we have, for instance, we have less than high school, LHS, we have high school, we have bachelor's, and we have graduate, I believe are the 4 categories here. So for less than for high school, for instance, there's 24. I think graduate, there was 6. And I believe, if I remember correctly from last week, bachelor was also 6. So the idea being, if you were calculate or count up each of these, you could find out that whatever the biggest category is, and this one it's pretty obvious because it's 24, and we know this is out of 40. So if in this case, high school would be the biggest category. And you can do the same thing for any one of these if you were to count up whichever age has the most. And mode means most, or the biggest number. It could be the same thing for percentages. So this was broken down into a chart, and you saw that 20, let's see, out of a category of, let's say, 10 people, and you asked the people if they liked a particular movie. So 8 people said yes, and 2 people said no. So you would look in this and you'd see whichever category was the biggest, 8 was the biggest. So this is the mode, or the most, of that category. So if you ever got a question that was looking at any set of numbers, it would be asking you what is the mode of this chart. You would go ahead and give the category of that. So this one, the mode below, and this one of degrees is high school. High school is the mode. And for an important thing to recall with most of these is when it's asking you for the mode, it's asking you for the category name. And this goes for basically any of the ones we're looking at. It's always asking for the category. So for instance, when we're asking for degree, the answer is going to be high school is the category, not the number 24. So when they're asking you for the mode, you're not looking for the number, you're looking for the category name. So in this case, what degree is the mode? High school is the answer. Okay, so mode is the simplest, you just look for the biggest number or the highest percentage. So that one's pretty simple. The next 2 are a little bit more complicated. So we'll look down. Here's another example of mode. Again, mode is the largest frequency or percentage. So if we're looking down here below, if I were to ask you, this is the 10 most common foreign languages spoken in the US. So you look here, and for instance, you're looking for what is the mode below, and so we're looking for the biggest number here. And fortunately, this one's actually organized from highest to lowest already. So you go ahead and see, oh, okay, so 37,458,624 people speak Spanish. So if they're asking what the mode is, the answer is Spanish, right? It's the category that we're interested in. We're not interested in the number. The number helps us find the mode, but it's not the number you're looking for. So in a quiz or a test, if they're asking you the question, they're looking for the mode is Spanish and not the 37 million number. Okay, and so the only other subtlety with this is there's some such thing called bimodal, meaning that there's 2 modes. So for instance, if you were looking through this chart and there was 2 categories that had 37 million, so for instance, let's say there was an English category, and English also was 37,458,624. then you could say this is bimodal, meaning there's two categories with the biggest number. And I don't think you run into that very often, but it's just something to know. So a mode is a category with the biggest category with the biggest number. Bimodal means you have two categories with the same number. Okay, so that one's simple enough. Let's scroll down to the next one. This one's also simple. The formula is pretty easy to understand, and there's only a slight modification. We'll go through an example so we make sure it makes sense. So median. Median is basic. If you think of this one, it's just another word for middle. Median means middle. So it's looking for the exact middle of a distribution. So the score that divides it in two equal parts. So if you're looking at this one, you would take the number of categories, in this case 6 plus 1 is 7 divided by 2. Well, actually, the better example for this is, well, let's actually go through this. This is actually supposed to look like this. This top poor one is not supposed to be on here. So let's try this again. So this one is the median is looking for the exact middle. The exact middle, so I actually leave that on there. Sorry. So median is the exact middle. So when you look at this number right here, you're going to count the number of categories. 1, 2, 3, 4, 5. And in this case, it's 5. And you're just going to fill out this formula over here. So if you're looking at the formula, n plus 1 divided by 2, we're going to run into n a lot when we're talking about this. We're going to be running into n a lot, and n simply just means the number of categories. So in this case, the n is 5 plus 1 divided by 2 equals 6 divided by 2, and that equals 3. 6 divided by 2 equals 3. So basically then you start counting from the top. You go 1, let's do it with a different color. Counting from the top, 1, 2, 3. So 3 is the median, and in this case, the category name is only fair. So let's go through that just one more time to clarify. I'll just clear this off. So as far as this goes, we're always going to be wanting to looking at it. Take a look at the formulas. Take a look at what numbers you have. So in this case, the formula is n plus 1 divided by 2. So anything you have, you go ahead and count the n up. In this case, is the number of categories, and there's 5. 1, 2, 3, 4, 5. 5. Put that formula up here. So we insert the 5 there. There's 5 categories plus 1 divided by 2, and again 6 divided by 2. Did this first. That equals 6 divided by 2 equals 3. So you go down and count the third category. 1, 2, 3 again. Only fair is the category. So median in this case would simply be only fair. Okay, so that one worked out nice because it landed exactly the third category. This number was an even number, so it helped us land on an exact category. So there's only a slight modification in this. So for instance, if we're to go down, and this is a chart I got off the book. In this case, if you were to count these off, let's actually, before we go into the steps, let's take a look at our formula here, n plus 1 divided by 2. In this case, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 divided by 2, that equals 9 divided by 2, and that's 4.5. So you see we've got a problem there. So we've got a problem because the 4.5 is going to tell us it's in between two categories. So we can't stop and simply say it's one of these categories. We have to do an extra step. So when doing this, and I have this broken up into steps here, there's 4 steps to this. So if this was your original, chart here, one of the other things you're going to want to notice when you're looking at something like this is if you notice here, the frequencies. If you look here, they're sort of random. There's no particular order to it. And the problem with median is because median is looking for the middle of the distribution. If you imagine putting these on a chart like this, And you start noticing when you start putting these numbers on here, you'll notice, like for instance, we see the biggest number is 759 would be somewhere over here, and 50 would be somewhere down here. So if you try to find the exact middle of this, you can see immediately it's not going to be between these two numbers, the ones you would count out. It's got to be some other number in here that's going to be in the middle. So part of that thing that reveals to us then is if you look in here, you start seeing that these things are not in order. And when you transfer that onto the chart, that's going to be a problem, because on any chart you're always going to have the lowest number to the highest number. So in order to make this make sense, in order for the formula to work, before we do anything, I will highlight this up here, you want to arrange your thing from lowest to highest. So if you were to get a homework problem and you were to try to, and they were to ask you then, to get the median, the first thing you want to do is make sure, is this from lowest to highest? So step one, arrange from lowest to highest. So in this case, I took this chart that they gave me, and I just started looking across and seeing where the numbers were. So the first one I noticed was 50. Pennsylvania was the lowest number. And the next one is 65 at Florida. And remember too, we're also interested in the category name, not necessarily the number. The next one we see is 109, which goes to Illinois. So Illinois is the next one. The next one is Texas at 145, Michigan at 311, New Jersey at 336, New York at 545, and finally California at 759. So now we got it arranged from lowest to highest, and now it actually would fit better on our chart, because you could see that if you actually put this on a chart, you would have lowest to highest already. Okay? So now that you've got it arranged from lowest to highest, now you can go ahead and do your median formula, n plus 1 divided by 2, and it's the same as before. We have 8 categories plus 1 divided by 2, and like we had said before, that'll be 9 divided by 2 equals 4.5. So this is our median number. So what does that tell us? That would tell us then, if we went back to our chart now, in our rearranged chart, you basically want to go then and count 4.5 categories down, since this is the number you're looking for. So this orients us to go here. So this is step 3. You now want to go down and count down 4.5. So I go 1, 2, 3, 4. And so 4.5 is going to be somewhere in between here. So we now know that somewhere between Michigan and New Jersey is going to be the answer. 1, 2, 3, 4. I'm sorry. Somewhere between, sorry about that. Let's try that again. Somewhere between Texas and Michigan. Sorry. Here we go. So if I could count, 1, 2, 3, 4. So 4.5 would be right in between Texas and Michigan. As you can see now, there's 4 categories below, and there's 4 categories above. So now we know 4 categories above, 4 categories below. Now that we have it arranged and we have it split, we know then that somewhere in between Texas and Michigan is our median number. So that means there's one final step. So all you're going to do is take the numbers that you have for these two and get the average, because you want to find the exact middle. So what that tells us to do is, that's 145 plus 311 divided by 2. So then you would go ahead and take out your calculator or take out your Google calculator. So 145 plus 311 is 456 divided by 2. And you get the number 228. So this number then, you know then that right in between here, you know 228 is exactly in between Texas and Michigan. So if you were to transfer then this up onto our chart, you scroll out a little bit here. If you were to transfer this back up onto our normal curve, remember we had the 759 here. I'm basically just taking this one down here. I got 50 on this end. You can now see that the number 228 is right here in the middle. That's the one that cuts exactly in half. So there'll be 4 categories on this side. There'll be 4 states over here. 1, 2, 3, 4. And also 4 states over here. 1, 2, 3, 4. So we know that Pennsylvania, Florida, Illinois, and Texas, these 4 are in this area. And we know that these four, Michigan, New Jersey, New York, and California, are on this side. So 228 then is the magic number that splits them exactly in two. So as you think through this, it's you just, as long as you follow these 4 steps, you'll be fine. And I think the thing that I would like to encourage you to remember the most is always arrange from highest to lowest. Because if you were to skip this step, you would come up with a very different number. So for instance, if you just directly took these numbers up here and put them in, you're going to end up with a very strange number. Because you're going to be looking at, you'll be taking these two, 5, 45, and 50, and dividing those by 2, it's not going to get you the same answer. So whenever you're finding the median, I'm going to go ahead and make sure you're doing this. Arrange it from highest to lowest, or I'm sorry, from lowest to highest. Use the median formula, n plus 1 divided by 2. And then you go ahead and find the in-between number. In this case, when we found it, it's split exactly between Texas and Michigan. So the number was 145 and 311. And then you go ahead and we added those together. 145 plus 311 divided it by 2, which is 456 divided by 2. And we got the final answer of 228. So if this were on the homework, something like this, if they're asking what the median of this was, the answer you're going to put in is 228. That's the final answer. Okay? So go ahead and go through that a few more times and it'll start making more sense. So median, easiest thing to remember is median just means middle. Mode means most. And average then, the final one we're going to look at is mean. So mean is probably the one you're most familiar with. So if you've ever tried to calculate your grade in a class, if you got, let's say you got, the class only had 5 assignments, so you got 3 assignments in your class, so you add them all together. So this is, say this was test 1, test 2, and test 3. If you wanted to get the average, you would know you do 10 plus 10 plus 8. You get the number 28. And then if you've done this before, you divide it by 3, because there's 3 total tests. 1, 2, 3. And when you do that, you do 28 divided by 3 equals about 9.3 would be your average score on your tests. So this is the same idea here. And there's a formula for it. And the formula isn't to complicate things, but to get you used to things. So this is the formula for calculating mean. And the thing we're going to start seeing a lot is here we have the n number again. Here's n again. And n is just the number of observations or cases. So in this case, with our test example, we had 3 tests total. And the other symbol you may not be familiar with is this one that looks sort of like an E, a backwards E. And that one just is sum. So that means you add up all your scores. Sum of y. So in this case, our sum was the test scores of 10, 8, and 10. So we added them together. And that all equals, this one here, the little symbol here, the y with a little hat on top. That just means the mean. So whenever you see that, it's telling you to look for the mean. So let's go ahead and do an example here. So if we were to take the average age of everyone in the class, say there's only 10 students in the class. So we would take the ages, in this case, 21, 32, 23, 41, 20, 30, 36, 22, 25, and 27. And you add all these together. You don't have to do it by hand. If you add it all up together with your calculator, you get the number 277. So that's if this number right here then, this 277, refers to this part up here, the sum of y. And then you're going to divide it by 10, because we know there's 10 students in the class. So you end up doing the equation, our 277 we had divided by 10, and that equals 27.7. So if someone were to ask you what is the mean or average age of somebody in the class, you would say 27.7 years old. Okay? So this one is simple enough. If you were to ask this, I think our questions look more like this one. you would just add everything up with your calculator, make sure you get all the numbers, divide by the number of people in the class in this case, or number of test scores, or whatever the number is, and that will be your answer. Okay? So that one's probably the one we're most familiar with. So before we go into final thoughts, just do another quick scan through. So again, mode is something that is most. So when you're asked for the mode, you want to find out whatever category has the biggest number or biggest percentage, and that one will be your answer. Median is the one that splits it exactly in the middle. So median is always going to mean middle. As far as we're concerned with that one, the key thing to remember is always arrange from lowest to highest. Otherwise, it's not going to accurately map onto our normal curve. Lowest to highest is what the curve looks like. So just try to remember that. And then you use your formula, n plus 1 divided by 2. And with practice and repetition, it'll start getting familiar. And as we go through the last one, the final one is mean. And that one you simply, whatever scores they give you, you're going to add them all up and divide by the number of cases. Okay? So the final thoughts here. Just the things to know with averages, I have two final thoughts. One of them is sensitivity to extremes. So basically that mean or average is sensitive to extreme numbers, and they might really affect your distribution. So for instance, and you can think about this with test scores. So say for instance, we go back to our example of 10, 10, and let's say 2. So let's say you had tests, and there were 10 questions. You got 10 out of 10 on the first one, 10 out of 10 on the second one, but 2 out of 10 on the last one. All this sensitivity to extremes is trying to tell us is that this score right here is really going to mess up your average. And maybe you've noticed this before if you've ever taken a class and you did really well on most of your tests, A's and B's, and then you failed one, and that could really drop your score. So sensitivity to extremes just means that if you have one number that's really different than all the rest of them, it could really affect your score. Same thing if you had a classroom full of students. If everyone got A's in the class, but 1 or 2 people completely failed the class, that could affect the overall average of the grades in the classroom. And we don't need to go into this in too much detail, but it's sort of the idea. They have a seesaw principle right here. They talk about basically if you have basically the same weight people here, if you look, so if somebody were standing on a seesaw, like you see, if someone was 60 pounds on one end and 120 pounds, and depending on where the person sat, that last extreme number, if it was 180 versus 240, it could really affect the overall average and how the seesaw, for instance, ends up working. So all this trying to get at is one really big number or one really low number, an extreme number, can really affect your overall distribution. And so the final thing to look at before we wrap this up is looking at your type of distribution. So basically what this is getting at is this idea is trying to look at this, how if you're looking at these normal curves down here, for instance, is trying to get at how you characterize that. So it's really simple. There's only 3 categories, and it all has to do with how, sorry, let me just delete this. So it all has to do with where the mean is in relation to the other 2. So this first one right here. So look at how the mean is related to the other 2. So for instance, if the mean is greater than the other 2, we call it positive. If the mean is smaller than the other 2, it's called negative. And if the mean is the same as the other 2, it's called symmetrical. So that's the word form. Down here is the picture form. So if you look here on the charts, right here, we see that the mean is bigger than the other 2, median and mode. So it's positively skewed. Whereas over here, we see that the mean is less than the other 2. Mean is smaller than median and mode. That's negatively skewed. And the final one, when you see them all the same, that's just called a symmetrical one. And the reason it's called symmetrical, because if you look down this middle, these 2 sides here are exactly the same. So these 2 curves are measured exactly the same. So it's like a butterfly. It's symmetrical. It's the same on both sides. So again, You're always going to be looking at mean is the important one here. And you see the mean here is the same, so it's symmetrical. The mean here is less, it's negative, and the mean here is greater than, so it's positively skewed. So these things will all help you as far as you take a look. So with practice, and it's okay if these things don't necessarily seem familiar right now, we'll be taking a look at them in multiple ways throughout the next few weeks. So they'll really start making sense as we start applying them.